Hey, how's it going? Welcome back to the mini-series of writing our own entity component system. So, a quick recap of what we did last time. We introduced IDs and the ID class, and we introduced the entity manager, where we could create and destroy entities, and then we created a small test app where we could test that entity manager, and it all worked, so luckily. In this episode, we're going to create the component manager, which is the manager that will store and manage all of the component data for each of the entities that we create. Let's jump right in. All right, so this is where we left off. This is our test app. We had an entity manager, we can create entities, we can get their IDs, we can get the entity count, and we can destroy entities, and we can run this app and show that that works here. Perfect. But today we are going to focus on ComponentManager.hpp. And this is important because this is where we're going to store all of the data for our entities. And we need to make sure that we do it in the fashion that I spoke about in the kind of ECS explanation of contiguous arrays. So let's do that. If I could type component manager. Component manager. And let's just delete all of this stuff here and here, and set this to default, and set this to default, and set all of these defaults to delete. I don't want it to be copied or movable at the moment. Let's just quickly go over the responsibilities of the component manager so that we know kind of what we're focusing on. So number one, we need to be able to register components, and these components should be any type of component. And that's because I'm going to allow the user to register any component that they want. So if you want to make a component called Dan component, and you want to make a component called fun component, all of those components could be registered, and any of those components can be attached to an entity. I don't want it to be so that we only have a kind of a set of components that are possible to be used, and then therefore we're kind of limited in scope. It might mean though that your game only has a specific amount of components that you could use, but you just need to register them all before you kind of move forward. It's not like a compile time thing. Secondly, we want to be able to add components. So add any type of component to any entity ID. Pretty straightforward. Third, we want to be able to remove a component. So remove any type of component from any entity ID. And fourth, we want to, what do we want to do? We want to be able to inform the component manager when an entity has been destroyed. And that's because we need to make sure that all the components kind of remove their references to a specific entity as it no longer exists. And we want to be able to get a component because we need to be able to get components of specific entities out of the component manager. Let's just keep that pattern. Entity destroyed. Perfect. So I think what we'll do is we'll start from the top. Let's start filling out our registry components. And let's go. So when we register a component, what do we want to do when we register a component? We effectively need to understand what component that we are registering, what type is the component that we're registering, and we need to kind of get some ID back. And for that, we're going to do the same thing that we did with entities. We're going to create a component ID. And this will look like this. I'm going to use size T I'll kind of show you why later. But in this sense, we're not going to use a static tag. We want to use a template tag. And that's because we don't, like we said before, I don't want to restrict components to a specific set. So let's type this out. So here we can create a component ID of loads of different types. And this also gives us a little bit of type safety, which I'll show you later. And therefore, when we create a component, or when we register a component, let's type this component type, register components. So when we register a component, we're going to get a component ID back, and then we'll use that component ID whenever we want to kind of add a component to a specific entity. And if we need to make sure that the component ID that we return is unique, and therefore we will have a count for that. And for the moment, we'll just use a slice t. And we will make that component ID, component index count ++. And now we could just return this component ID straight away, but that's not very useful because we now have a component. The user has told us that they want to register a component of this type. And therefore, entities are going to create components. And therefore, we need to be able to have somewhere to store that component data. And for that, we're going to have an array. And in that array, we're going to have unique pointers of a thing called an iComponent array. And we're going to have a maximum component count for this. And I will get onto why this is in a bit. Let's delete this. And let's, for now, just make a placeholder class for iComponent array. And we also need to add array, and we need to add memory. And I've got a maximum component count here for our component manager. So this is happy at the moment. Now, how do we create an iComponent array for our component type? Now, this means the reason why we need this interface here is because of a reason that I will show later. But for now, just stay with me and we'll get to it. So I'm going to make another class called component array. And that is going to inherit from iComponent array, like this. And for the moment, let's just add a virtual destructor. Well, yes. And then component array is complaining because it also needs a have its own constructor. Okay, so actually, I'm just going to do that now. Okay, so what we're going to do is we're going to create an array of iComponent arrays. And when we register a component, we're actually going to create a component array of this component type. Therefore, this component array needs to be templated. Type name, component type, like this. And what will happen is we are going to instantiate or std make unique into this components array. And the component index count or the component ID will be the indexed, will be the index of that component type in this components array. So what we can do is we'll just get that component out, and we're going to do a std make unique component array component type, like this for the moment. Yes, that should be good. So now basically whenever we want to access a specific component type in this components array, we will just take the component ID, and we know that that component ID now matches the position in the components array. So hopefully, if you're unsure, this will become more clear later on when we do kind of some examples and stuff. But let's move on to the next function now. So we're going to create add components, and later on we're going to add some, no, let's add it now. We're going to add some error handling, just in case, just for some extra safety, I think. Component type. And now if you remember, oh, let's add error. I'll just do it myself. Error.hpp. So if you remember here, I said we want to add components for a specific entity ID, which means we're going to need an entity ID. We're also going to need a component ID. And the reason for this is because I return an ID because I don't want to do any runtime type resolution, because I think it will be slow. And therefore, if we can just index into an array instead of kind of trying to understand what the component type is that the user has provided, then it's going to be much quicker. And we'll see that working later on. So when we want to add a component, we need to know what entity ID it is, what component ID it is, and therefore also what the actual component is. And there's some safety here, because these two types have to match, which means that you can't provide the wrong component ID with a different kind of component. So that's good. Now also I want to just make sure that id.get that the component ID is an actual valid component ID, and that we don't go out of bounds. And therefore let's just do a quick sanity check there. So we're basically just saying, if the component ID that you've given me is greater than the index count, then it's not valid, which means that somebody has created a component ID themselves, and they shouldn't have. So if we're going to add a component, we need to basically access the iComponent array in this std array, and then add a component to it. So let's kind of just get that out. I won't use auto right now because I want to show you what type it is. So the idea is that we're going to want our component array of type component type that we're adding to, and therefore we need to get that type out of this components std array, and we're going to do that by static cast, and we're going to go component array, component type. What am I doing? This components component. If you remember, I said that the component ID matches the index of the correct component array inside components. So what we're going to do, we're going to get the iComponent array unique pointer from the components std array. We're then going to get the pointer out of std unique, and we're going to cast it to a component array of the correct type. And we know that's safe, right? Because these are the rules of this class that I've set up. And then what we're going to do, and we haven't actually got this function yet, but we're going to go entity ID component. And then we're going to return error. Okay. So let's move on to now like implementing this add component function, because this is where kind of it makes most sense for us to go to, I think. So now we need to implement this add component function inside component array, and component entity ID const component type component. Keep that up there. So when we add a component, we need to make sure that all of our components for that type are in a contiguous array. So we're going to use a vector here. And I understand in much of the design that I've used here, there will be bugs and there will be kind of performance improvements that we could make, but that's stuff that we could do for a later video. And if we find issues, then we can kind of improve it. But for now, this is what I'm going to do, and I think I'm happy with it. So we're going to have a std vector of component type, and we're effectively just going to push back onto components our component, right? And that gives us kind of that allows us to push this component onto kind of our vector here. Now, I suppose we could place back for now, which I think will help in the future if we kind of construct in place, depending on the type of component type. But again, this is future kind of optimizations. We can sort that out later. So then now, if we think about it, how do we know what entity ID matches what component inside the components vector? So we're going to kind of have some way to track that. And for now, I'm just going to use an unordered map, which we will call entity index map. Index map, and we will ID equals, no, what are we doing? Yes, ID equals components dot size -1. So this is effectively pushing that component onto our list because we're adding it, and we now are going to map, we're going to track what ID matches the component that we've just entered based off of the back of it. Now, we need to fix an edge case here, because imagine if we now did kind of remove component for a specific ID. We need to get the index from the entity index map and then remove the component from the vector. But the problem there is that we won't necessarily remove it. We'll just kind of flag it as dirty or whatever. And therefore, we're going to have to track the free slots again in this vector, very similar to like what we did with the entity manager. So I'm going to do the same thing. I'm going to have a queue of size t, and we're going to call that free slots like this. And with this queue, we're going to track our free slots. So, for example, let's presume the free slots queue isn't empty. And so we can comment afterwards. So if the free slots queue isn't empty, that means that there is some fragmentation in our components array, and we want to make sure that we fill that first. Now we could we could do a proper arrays in our vector, but it would shuffle our memory around a lot, and I think that's quite expensive. Again, we can profile this later on. It might be a better strategy, but for now I'm just going to do it this way. So what we need to do, we want to get the index from the free slots front. We then want to update the index in the components array, because now we're going to replace the component in this, we're going to replace the component in this vector here with this index that's free. We are then going to update the entity index map with this, and then we're going to pop the front. So it's relatively simple. We take the front index off of the free slots queue, we then update the component, we update the index map with the new ID, and then we pop. And that should be everything that we need to do. Now, in regards to removing a component, what we need to do is we're going to use the entity index map to see if this actual kind of component exists within this, if this entity exists within this component. So let's create an iterator, and we're going to do entity index map.find ID. And then we're going to compare the iterator with the end of the map, like this. And then what we're doing here is basically saying if the entity iterated doesn't equal the end of the map, then it must exist in this map, and therefore this entity must exist within this component array. And all we're going to do is effectively push the index onto the free slots. And the reason we can do that is because the entity index map returns a reference to, I suppose you can see here, returns an iterator to a stood pair of the ID, and so on, the const ID and a size t, as in the index. And that index can be accessed by dereferencing the iterator and then accessing the second part. And what we also need to do is now we need to erase the ID from the index map. And the reason we need to do that is because we now want to make sure that, well, we know that this ID is no longer valid. So we give it to the free slots, and then we also kind of erase it. Now we're getting an error here because the unordered map needs a hash function for the ID class that we created. So let's just go and create that quickly. And to do that, we need to override the hash function in our for our ID class in the standard namespace. Now, this isn't generally allowed, but this is one of the reasons why. This is one of the places where you are allowed to kind of do overriding inside the standard namespace, and for exactly this reason, for creating kind of hash functions for your custom types. So this, and then I'll explain kind of what this is doing. So what are we saying here? We're saying basically the hash function for this is a specialization for the ID type. The specialization struct for the ID type, whereby it has an operator overload of the brackets operator, whereby it returns a t, and that t is effectively just the ID out of the component ID. And the reason why that works is because we know from the component manager that component IDs are unique. You can't create more than one. You can only have one component ID with the same ID. And that's fine. So therefore that should be okay. Now, are we happy with this? What can we do? We can add a component, and we can call in here, and in here, what we'll do is we'll check if the free slots are empty. If it is empty, then we will just in place back onto the components and update the map. If it's not empty, then we'll take the front slot and we will just update that component, and voila, we're done. Now, the next thing, remove component. Let's write that. So this is where I'm going to create the only kind of virtual interface. Sorry, the only virtual function that the component array needs to override, and that is this remove component function. And the reason for that is because I don't want, sorry, let me just remove component entity ID equals 0. So to remove components, we don't actually care the type of the component, or we don't actually care about the components that this entity ID actually has. We just care that all the components attempt to remove this ID from their component array. And therefore, we don't need to have it templated, and all we have to do is kind of iterate over this components array. Like this, and call, what am I doing? Oh, sorry. Remove component ID. And that's it, right? So because we have a virtual function, we always know that our component array implementation will always have a remove component function. And that's this effectively. And then if we want to remove a component, all we do is iterate over all the components that we have and kind of remove it. Now we could, in the future, kind of, again, we could, oh dear, what have I done? Let's fix this. Okay, sorry about that. In the future, we could kind of optimize this by, for example, tracking, like just doing a for loop over the amount of component index counts that we have, so that we can guarantee that we don't go over all of the unique pointers. And also, we probably want to check if component is valid, because it's a unique pointer, and therefore we don't want to call anything on it without that being the case. So what was next? Remove component. Oh, I think I've got this mixed up. I've created entity destroyed. So we're going to do that. And then now we're going to add a remove components function. And I think remove component will just be effectively exactly the same as add components. But this is where we target a specific component ID. Remove components, and we don't need to know that. Yeah, that's fine. So in remove component, we don't need this either. All we need to know is what component do you want to remove, and what is the ID that you want to remove, the entity that you want to remove that component from. And all we'll do is we'll index into that array, get the component array, and then tell the component array to remove the component for that entity ID. And then for entity destroyed, we're going to do that for all components that are valid, and that should be fine. Okay, what was the last thing? And then lastly, number 5, get component. So get, we're going to have to template type name component type component type. I'm going to return a reference for that. And what we need to know is we need what entity do you want to get that component for, and then also what component do you want to get. So let's steal this because this is very similar. And we now have our component array, and we're going to return component array get component like this, entity ID. And now what we need to do is we need to fill in this implementation for get component. So we're going to do component type, reference, get component, entity ID, and we can components, return components, and we're going to effectively just entity index map dots ID. I think that's right. So what are we doing? We're indexing into the entity index map here with an ID, and we're getting back the index. And then all we're going to do is return a reference with the operator brackets in from that components list and return that. And then that returned component can be adjusted however you like, effectively. I actually don't. I'm going to fix this now because it's just asking for a problem, right? I is less than component index count plus I components I remove components ID. That's better. I'm happy with that. Now we just kind of only iterate over the amount of components that we have, and that's much nicer. Okay, is that everything that we need to do? Let's think about it. So I think so. I'm going to just create a new file for this component array stuff because just to tidy it up a bit. Let's put this in here. And quick header guard. Include ECS component array. Let's just include all the things and bits and bobs that we need, like unordered map. I don't think we need that here. What do we need here? We just need array. So let's just steal this. And we need a vector. And we need include IDs. And that's fine. And then we need here to include ECS component array. Everything's happy. Okay, now I think what we should do is we should try and put this into our app. One, we're going to see where it fails to compile, and two, we're going to play around with it and make sure that we're happy with everything. So let's first of all, let's just create a component manager. Okay, that's fine. And now let's register a component. And we're going to create a component called, what were our entities before? There was nothing special. Okay, let's create a component called animal size. And this is just going to be a list of ints for feet size, head size, face size. And what we're going to do here is go animal size. And then if you remember, what we should get back is a component ID of animal size. Animal size ID. Oh no, comp ID. Like this. Let's build that. Make sure it builds. Yep, that's fine. Okay, cool. So now we can we've registered this component, and now the component array for this component is inside the component manager, and we're good to go. So now what we can do is we can actually register some components with the entities that we've got. Now, if we run this, here we should have only one entity in the component manager. Sorry, we should have only one entity in the game because we've destroyed 1, 2, 3, and now we've just created a new one called entity 4. So let's add an animal size component to entity 4. I'm just going to call it this. Feet. I'm going to say this is equal to 1, it's equal to 2, it's equal to 3. And then update this. So now we're going to Component Manager, add components, entity 4. That's the component that we're interested in. This is the component ID that we're going to add, and then this is the component. Animal size entity 4, like this. So what are we complaining about here? And remember, entity ID is actually a result type, so we need to dereference that. And does that work? Let's see. That seems happy so far. Okay, so what have we done? We've registered that component type with the component manager, so it's happy. We've now created a component to add to our entity. And now, I suppose, let's get the component back out and make sure that that component reflects what we've added here. Animal comp. So here we're saying for entity 4, give us the animal size component. And we're going to, I suppose we'll do this. Animal size reference, entity 4, animal size component equals. And then we're going to do some printfs. Entity 4, animal size feet equals dot feet. And let's just kind of do them all. Head, face, head, face. All right, I really hope this works. Let's see. Hey, perfect. A rookie mistake. Okay, cool. So what are we doing here? So we've registered a component. We've added that component here. And now we are we've added the component to entity 4. We now get the component back out on entity 4 animal size, and then we print, and that works. Now, you could imagine later on, if a system was kind of pulling this component out and it wanted to edit it, we could update this, and we could go face equals 99, head equals 1000, and feet equals 27383. Let's put that in the right order so it's not confusing later on. Cool. And then if we, just to prove that we can kind of get, just to prove that the data that we're updating here is a reference to the data inside the component array, inside the component manager, let's get the same component back out again with get component called this, and then we're going to print that again, and hopefully it should be updated. I hope. And the reason why I'm doing this is I don't want to just be like, well, I've updated this and then print that again. It would be silly. I want to update this, then get the component again, and then print it again, and hopefully it should have updated. Hey, look, perfect. So let's just go through what we're doing here. So we've created a component manager. We can register a component type. We can add components. to a specific entity, and we can get that component back out and we can see what the data is inside of it. We can update that component with the reference from the component manager. We can then somewhere else in our system get that component back out and see what the value was. And I think that should be it for today. In the next video, we're going to do systems. All right, there we go. So that's the component manager finished. Now, there's definitely bugs, and the performance probably, well, most definitely can be improved later on. But for now, I think I'm happy with how it's working out. We've shown the component manager working in the test app, and we've shown how I avoid kind of runtime type resolution, which I think is important. And in the next video, we're going to do the system manager, and that will include kind of registering systems in the same way and kind of getting systems back out, and then using those systems to iterate over the entities that we care about with a system signature. That video might also include the ECS controller and the entity wrapper, where it makes it a lot easier to use entities and handle them. But if the video becomes too long, then I might just move that onto the next video, and then we'll be finished with the ECS and we can move on. I hope you enjoyed the video and you learned something, and if you did, then please feel free to like and subscribe so that you don't miss out on the next one where we do the system manager, and leave some comments as well, because I really appreciate that and I love hearing from you and replying when I can. So I think that's all. Cheers, and I'll see you in the next one.